Welcome, curious minds, to the deep dive. Today we're embarking on a truly captivating exploration of one of history's most enduring and, frankly, scientifically perplexing artifacts, the Shroud of Turin.
It really is fascinating. For centuries, this linen cloth, bearing the faint image of a crucified man, has inspired, well, fervent belief, rigorous skepticism, and an unending stream of scientific inquiry.
Exactly. It's a mystery that isn't confined to dusty historical texts. It's a living scientific puzzle. It continues to challenge our most fundamental understandings of, image formation and material science.
That's right. And our mission today isn't really to venture into theological debates or historical controversies, fascinating as those are. Instead, we're sharpening our focus specifically on the scientific image characteristics of the shroud. We're going to systematically unpack what's been meticulously categorized by researchers as Class 1 evidence. This is basically a collection of 17 unique features observed in both the body and the blood images, features revealed through decades of rigorous, modern scientific research.
Absolutely. And these aren't just a random list of observations, are they? These 17 characteristics are considered paramount because, taken together, they provide enough scientific data to critically evaluate all of the major image formation hypotheses proposed to date.
Exactly. So we're aiming to cut through some of the speculation and get straight to the observable, testable facts that really define this enigma.
Our deep dive today is grounded in a close study of Section 4, Image Characteristic Evidence, from a key scientific source. This particular section gives an incredibly rigorous and comprehensive overview of these empirically observed properties. It really sets the stage for an academic level of understanding.
Right, we're diving into the hard data.
So what can you expect from this deep dive? Well, you'll gain a serious shortcut to being incredibly well-informed about the precise physical evidence of the shroud. We're talking about surprising facts and insights that go far beyond the surface-level discussions you might encounter elsewhere.
It should equip you with a nuanced understanding that's rooted firmly in scientific observation.
Exactly. This is your chance to really see the shroud through a clear analytical lens, moving maybe from mere curiosity to a truly informed perspective. So let's unpack this fascinating artifact.
Okay. To begin our exploration, let's first focus on the image characteristics directly related to the cloth itself. These are sort of foundational properties, crucial for understanding the intrinsic nature of the image before we even consider the human figure it depicts.
Right, starting with the basics of the image on the linen, let's start with something fundamental. It's optical density. What's truly striking, and this is our first characteristic, C1, is that the frontal and dorsal body images, so the front and back of the figure, they have nearly identical optical densities. Now, for those maybe unfamiliar, that simply means their relative lightness and darkness are essentially the same across both impressions. This is a key finding by SNRP, the Shroud of Turin research project, way back in the late 1970s.
That's a really significant observation, because when you view the shroud directly, just with your own eyes, it's genuinely difficult for normal human perception to discern which image, the frontal or the dorsal, appears more prominent. Their uniformity in shading creates a visual ambiguity that's, well, quite peculiar. The STIRP researchers, using specialized photometric measurements, not only confirmed this, but also noted something else interesting. The shroud image is continuously shaded to some degree over its full extent.
Meaning
The very thread fibrils themselves are discolored everywhere the image appears. The only exception, notably, is within the discrete blood stains.
it makes you wonder, doesn't it? Why is this uniformity so important? I mean, if you were trying to create an image using traditional artistic methods, say painting, or even a simple contact transfer like a rubbing,
Right.
you would inherently expect variations in density, wouldn't you? The amount of pressure applied, the quantity of medium laid down, the way a brush stroke falls, all of these would naturally lead to areas of greater or lesser optical density.
Absolutely. Unevenness would be almost unavoidable.
Yet here we see this near-perfect uniformity across both a frontal and a dorsal impression. It suggests a very specific, highly controlled, and perhaps even non-contact image formation process, something that bypasses the variables inherent in manual application.
Precisely. This uniformity immediately challenges those common assumptions about how such an image could have been created artistically.
Okay, so that consistency is key. What's next?
And this leads us directly to C2. The extreme superficiality of the image is another major one. It means the image resides only on the very outermost surface of the cloth threads. The inner fibers are left completely uncolored. It is, to put it mildly, astonishingly shallow.
Wow. When we say incredibly superficial, what are we actually talking about in terms of scale?
We're talking almost microscopic precision. Look, the linen shroud cloth itself is nominally about 0.014 inches, or roughly 0.35 millimeters thick, so it's not a thick canvas to begin with.
Right, pretty thin linen.
Very. The individual threads making up this cloth have a mean diameter of about 0.10 inches, or 0.25 millimeters. And each one of those threads, in turn, is composed of 70 to 120 much finer linen fibers.
Okay.
Now, these individual fibers average between 0.00004 and 0.0008 inches. That's 0.010 to 0.020 micrometers in diameter.
Micrometers, just to put that into perspective, that's generally smaller than a human hair.
Exactly. It's incredibly fine. To help visualize this, you could imagine Figure 76 from the source, which is a colored photomicrograph of image fibers at the bridge of the nose, one of the more densely colored areas on the shroud. Even in such a region, the photograph subtly hints at this extreme superficiality. But it was really Stirp's high-powered microscopic examination, done at 32x and 64x magnification, alongside their transmitted light photographs, that truly reveal the full details.
How so?
Well, they were able to meticulously contrast the faint superficial image with much darker fire-related scorches on the shroud from the 1532 fire. Those scorches notably penetrate much deeper into the cloth's fibers.
Ah, I see. So the image is fundamentally different from a burn mark.
Fundamentally different. This stark contrast underscores just how unique the image's superficiality is. It differentiates it completely from any simple thermal mark.
And the research on just how superficial it is continues, right?
It does. Here's where it gets truly fascinating. Ongoing research, delving even deeper, suggests that the color might be confined to an almost unimaginably thin layer, possibly as shallow as 0.2 micrometers thick.
0.2 micrometers, that's tiny.
It's believed this might be the primary cell wall layer of the linen fibers, leaving the interior cellulose virtually colorless and undamaged. Now, while this exact depth is still an active area of research and maybe not definitively confirmed across the entire image, it points to an incredibly precise and shallow interaction.
Someone called it a molecular suntan, I think.
That's a good analogy, almost like that. STIR-RP member Alan Adler, a renowned chemist, reported something remarkable. This thin colored layer could be chemically reduced using a specialized Demide reagent.
Reduced meaning?
Meaning it removed the color. Crucially, this process left behind colorless, undamaged linen fibers. This demonstrated scientifically that the coloration was indeed a chemical alteration of the fiber's surface, not some permanent embedding of foreign material.
Okay, so it's a chemical change on the fiber, not something added to it.
Precisely. Furthermore, research back in the 70s and 80s demonstrated a phenomenon that is visually quite striking. Stirp used sticky tape samples to lift material from the shroud for analysis.
Right, I remember reading about that.
Well, in many cases, when they carefully removed these tapes, they had actually pulled off this extremely thin colored layer from the image fibers.
Pulled it right off.
Yes, leaving behind what are often referred to as ghosts of the image, physically attached to the sticky tape samples themselves. You can see this in Figure 77 in the source. Imagine a thin colored film, literally peeling off the fibers and adhering to the tape, leaving behind the colorless linen beneath.
Wow. That really highlights not only the extreme superficiality, but also the incredible fragility and distinct physical nature of the image layer itself.
It's as if the image isn't intrinsically part of the fiber's bulk, but rather a distinct, incredibly delicate surface phenomenon. Almost like a decal, but chemically part of the surface layer.
So what does this all mean when we try to understand how the image formed? I mean, how does such extreme superficiality effectively rule out conventional artistic techniques like painting or staining?
Well, think about it. With paint, regardless of its medium, you'd expect pigments or dyes to penetrate the fibers to some degree, wouldn't you?
Sure, they'd soak in a bit or at least leave a residue.
Exactly. Or at the very least leave a discernible coating or residue on the surface that would be thicker and more adherent. The shroud image, however, is an alteration of the fibers themselves, a chemical change to their outermost layer, not an addition of foreign material to them.
So that instantly discredits theories involving brushes, pigments, or contact staining methods that rely on liquids or viscous substances.
Pretty much. And that ghosts phenomenon suggests the image layer isn't only incredibly thin, but also physically distinct and fragile, almost like a separate, peelable layer that's utterly inconsistent with any known ancient or medieval painting technique.
Okay, that's incredibly specific. Superficiality is key. What's next?
This brings us to C3, the double superficiality of the frontal image. While the previous point highlighted the image's extreme shallowness on the front, this characteristic reveals an even more puzzling aspect.
Double superficiality, what does that mean?
It means that the fabric, which remember is only about 0.35 millimeter thick, at least in the facial area, presents a superficial image on the front of the cloth.
Right.
No image whatsoever in the middle of the cloth.
Right.
And then another very faint superficial image on the backside.
Wait, an image on the back too, but only superficial.
Exactly. Superficial front image, nothing in the middle, superficial back image.
That's an astonishing detail. We should probably remember the historical context here. After that devastating fire in 1532, the poor Clare nuns meticulously added patches over the burn holes and sewed on a protective backing cloth, the Holland backing cloth.
Right, that covered the back for centuries.
And at that time, while penetrating bloodstains were certainly documented and visible on both sides, there was no mention, or indeed any visible evidence, of any image on the backside of the shroud.
Correct. The discovery of this double superficiality came much, much later. In the year 2000, parts of that Holland backing cloth were carefully unstitched. This was done to allow scanner access for a more comprehensive examination of the shroud's backside.
Ah, okay, so they could finally see the back properly.
Precisely. Then, in a groundbreaking 2004 paper titled The Double Superficiality of the Frontal Image of the Turin Shroud, researchers G. Fanti and R. Maggiolo reported on their meticulous studies of these new scanning photographs.
And what did they find?
They revealed a very faint image of the face, hair, and possibly even the hands on the backside of the cloth. But crucially, and this is the vital part, these faint backside images were perfectly in register with the corresponding frontal body images.
In register, what does that mean exactly?
It means they didn't just appear randomly. They perfectly aligned, almost like pixel for pixel, as if you could look straight through the cloth and see the front image precisely superimposed on the back image. This precision is another huge clue about the nature of its formation.
This is truly puzzling, isn't it? How could an image possibly manifest on both sides of a relatively thin fabric like linen without any discoloration or presence in the fibrous middle of the cloth?
It's a major question.
And that in-register alignment only deepens the mystery. It suggests a highly precise, perhaps even directional, formation mechanism. The faint image on the back perfectly mirrors and aligns with the frontal image. It's definitely not a random bleed-through or a simple dye penetration.
No, it implies a very specific, non-uniform interaction with the fabric that somehow bypassed the internal fibers completely.
Which logically leads us to C4.
Exactly. The absence of dorsal double superficiality. This is just as important as the presence of the phenomenon on the front. The same thorough analysis by Fanti and Maggiolo that discovered the double superficiality on the frontal image found no superficial image on the backside, corresponding to the dorsal body image, the back image of the man.
So this double-sided effect is only on the front image, specifically the face and maybe hands.
That's what the evidence indicates. The double superficiality phenomenon exists only for some areas of the frontal image, most notably the face.
This asymmetry is absolutely critical then for anyone trying to hypothesize about the shroud's formation.
It really is.
Because if whatever formed the image was some kind of uniform process, maybe penetrating energy or a diffuse chemical reaction, you'd logically expect it to affect both sides of the cloth similarly, right? You'd expect a dorsal counterpart to the frontal double image.
You absolutely would. But the fact that double superficiality is a specific feature only of the frontal image places significant, indeed almost insurmountable, constraints on image formation hypotheses.
How so?
It strongly suggests that the mechanism was not uniform across the entire shroud's surface. And it effectively rules out processes that would indiscriminately affect both sides of the cloth in a symmetrical manner. This differential characteristic is a powerful piece of scientific evidence.
Okay, so superficial, sometimes double superficial only on the front, and uniform density. What else about the image and the cloth?
Our fifth characteristic, C5, is fundamentally important to understanding the image's composition. The chemical coloration is due solely to chemical reactions involving the polysaccharides of the linen fibers themselves.
Meaning the linen's own chemistry changed.
Exactly. There is absolutely no evidence of a coating or any extraneous material applied to the fibers to cause the color. The yellow-brown color is a result of intrinsic chemical changes, specifically oxidation, dehydration, and conjugation happening within the linen fibers themselves.
This was one of the primary goals of the STURP scientific expedition back in '78, wasn't it? To test the painting hypothesis.
It was arguably the primary goal, to rigorously test the prevailing idea that the shroud image was simply a medieval painting, and their results were Well, to be blunt, unequivocal.
What did they find?
Stirp's extensive tests and subsequent meticulous analyses using cutting-edge techniques for the time, like laser microprobe Raman spectroscopy.
Which tells you the molecular structure.
Right, and pyrolysis mass spectrometry, which basically breaks down tiny samples to get a chemical fingerprint. They conclusively found no paint pigments, no paint mediums, and no other extraneous matter physically bound to the image-bearing fibers.
So a direct scientific refutation of the simple painting idea.
As it stood then, yes, it was definitive.
But people do find contaminants on the shroud, right? Like paint particles.
That's an important clarification, yes. This doesn't mean the shroud is entirely pristine and free of any extraneous material. During medieval times, it was apparently a common practice for artists to make copies of the shroud and then lay those copies directly on top of the original.
Sort of like a blessing or authentication.
Exactly. And that practice would, quite inevitably, leave minute traces of paint fragments on the cloth, and indeed some have been found. Iron oxide, for instance, a very common component in medieval paints and even ancient textiles, has been detected on the shroud.
Ah, so there is iron oxide. Doesn't that support the painting idea?
Well, here's the crucial part. The iron oxide found is evenly distributed over the entire cloth, in both image and non-image areas. The only exception is the bloodstains, where, as you'd expect because iron is in hemoglobin, it is highly concentrated.
So it's everywhere, not just making the image.
Precisely. This uniform distribution strongly suggests it likely originated from the natural flax retting process, that ancient method of soaking flax in water to separate its fibers rather than being an image-forming pigment deliberately applied by an artist.
So it's a contaminant, not the source of the image coloration itself?
Exactly that distinction. The key is that it's present, but not in a pattern that forms the image.
So this characteristic fundamentally and definitively argues against the image being a product of painting, staining, or any form of manual application of external material.
Correct. The image is a direct alteration of the fibers themselves, a chemical change within them, not an addition to their surface. This dramatically shifts the entire conversation about how it could have been formed, pushing us far beyond traditional artistic explanations.
Okay, and this ties into the next point.
It does, directly. C6, there is no sign of cementation or capillary flow in the image areas.
Cementation, capillary flow, what does that mean in this context?
Well, unlike the distinct blood stains and some historical water stains on the shroud, which clearly show evidence of fibers sticking together, that's cementation due to dried liquid residue.
Okay, like dried glue or something.
Sort of. And they also show capillary flow, where liquids have wicked through the cloths between the fibers. The actual image areas, specifically where the fibers are isolated from such stains, show absolutely no such signs.
Can you see this difference visually?
Yes, clearly. If you compare, for instance, figure 78 in the source, which shows a detailed view of blood on the shroud at the small of the back, here you can distinctly observe the cementation of fibers and the characteristic patterns of liquid flow.
Right.
Now contrast that with a view like figure 76, showing the colored fibers at the bridge of the nose. In the image areas, the fibers remain distinctly separate. They appear as if the color just somehow emerged on their surface without any liquid carrier involved.
So this further reinforces the point that the image was not formed by any liquid or viscous artistic medium.
Exactly. If a painter had applied a liquid or even a semi-liquid substance, no matter how thinly, you would absolutely expect to see some degree of fiber adhesion, some wicking, or evidence of the liquid spreading through capillary action.
But under powerful magnification, the image fibers stand distinctly separate.
Correct. This is fundamentally different from how liquids interact with fabric, and it effectively eliminates a vast range of traditional artistic or contact transfer methods that rely on fluids as a medium. It suggests an almost dry, non-contact process for the image formation itself.
What's truly remarkable here is the cumulative picture emerging. We're talking about an image that functions as a photographic negative, which I know we'll get into an image that seems to encode three-dimensional information. And now we've established that whatever created it didn't involve any kind of liquid, pigment, or extraneous material binding the fibers together.
It's a truly unique set of circumstances, isn't it? Defying conventional explanations at almost every turn related to the cloth itself. Indeed. Now let's transition. Let's move to the second powerful category of characteristics. Those related directly to the body depicted on the shroud. These features offer perhaps even more profound insights into the nature of the human figure that generated this enigmatic image.
Okay, let's dive into the body image itself. First among these, and arguably the most famous and perplexing characteristic, is B1, the negativity effect, the light and dark reversal.
That's right. When viewed directly in natural light, the shroud images display tones of light and dark reversed compared to what we normally perceive with the human eye in a positive image, like a normal photograph or painting.
This was the dramatic revelation, wasn't it? The real aha moment of the negativity effect back in 1898.
It was. Italian amateur photographer Secondo Pia was granted permission to take the first official photographs of the shroud during its exhibition in the Turin Cathedral, as he developed his photographic plates in the darkroom.
Which were glass plates back then.
Exactly, glass negatives. He was reportedly shocked to see that his negatives revealed previously unperceived details of an anatomically correct, naked and crucified man. Before this, people saw a faint, almost ghostly image. But on Pia's negative, suddenly, a clear, detailed, positive image of a man emerged.
It's hard to overstate the impact of that moment, right? Suddenly what had been observed for centuries as this faint, indistinct, somewhat ghostly figure on the linen transformed into a clear, detailed, recognizable human figure on a photographic negative.
You can really grasp this visual paradox if you compare Figure 79 in the source, which shows how the shroud image appears directly, like a photographic positive, subtle and reversed in tone, versus Figure 80, which is the photographic negative.
And on the negative.
On the negative, the body image springs forth with stunning clarity and anatomical detail. It reveals features that were simply imperceptible to the naked eye for hundreds of years.
So the immediate question is, what does it even mean for an image to function as a photographic negative centuries before the very concept of photography was invented?
Precisely. This characteristic, maybe more than almost any other, immediately rules out any direct rubbing or simple contact imprint. A contact imprint would always be a positive image.
Right, like a brass rubbing.
Exactly. Furthermore, it challenges any conventional artistic technique known from ancient or medieval times. Artists simply did not, and truly could not, conceive of or execute such a precise, inverse tonal effect, especially not on a linen surface that also exhibits all the other characteristics we've just discussed.
It suggests a formation process entirely alien to human artistry of that period.
That inherent photographic negative property points exactly that way.
Okay, that's an incredible paradox, truly baffling. And it seems to deepen with our next characteristic, B2. The image possesses high resolution, yet has undefined outlines, leading to what some call the vanishing effect.
That's right. The image has a resolution of at least 15 inch, or about 0.5 centimeters. This means fine anatomical details like the nose, the lips, the beard, even individual fingers are remarkably defined when you analyze the image properly, say with instruments. But here's the paradox. When you observe the actual shroud directly, closer than approximately 1 meter, about 3 feet, and some researchers, like Dr. John Jackson from STURP, even noted this effect up to 1.83 meters or 6 feet away.
What happens?
The image essentially disappears, or it becomes incredibly difficult to discern. It just sort of fades into the background weave of the cloth.
How can that be? High-resolution details, but they vanish up close.
It's the optical paradox you highlighted. Microdensitometer scans, which scientifically measure tiny variations in image intensity or density, consistently show these fine anatomical features with remarkable clarity and precision. This indicates a high-resolution encoding of information.
Okay.
However, when observing the shroud directly and up close with the naked eye, the extremely low contrast between the subtly colored image fibers and the uncolored background, combined with the complete absence of any well-defined outlines or borders, that combination causes this vanishing effect.
So there are no hard edges.
None whatsoever. You simply can't resolve the details at close range because there are no sharp lines to delineate the form. The image is built up solely from these subtle variations in the density of those incredibly superficial colorations we talked about.
And again, this stands in stark contrast to looking at the photographic negatives.
Absolutely. On those negatives, which weren't available until 1898, those fine details are resolved with striking clarity no matter how close you are.
So this combination, high resolution when scientifically analyzed, but a simultaneous vanishing effect upon close direct observation that profoundly challenges common image formation hypotheses.
It really does. Any simple painted or stained image would typically have defined borders and retain clarity even up close. The Shroud's image suggests something far more subtle, nuanced, and perhaps even non-linear in its formation process.
It's almost as if the image wasn't really meant to be seen directly by the human eye in its raw form, but was encoded in a way that required future technology to truly reveal its full detail.
That's one way to look at it. Which brings us perhaps to the most astonishing characteristic for many, B3, three-dimensional encoding, or distance correlation.
Right, the idea that it contains 3D information. How does that work?
This is one of the most unique and scientifically studied characteristics. The image density distribution, how dark or light the image is in different places, on both the frontal and dorsal images, correlates precisely to the distance between an object, in this case a human body, and the cloth covering it.
So simply put,
Closer equals denser. The closer the body part was to the linen, the denser or darker, the image appears on the shroud. This is why many researchers refer to the shroud as a truly three-dimensional image encoded onto a 2D surface.
that characteristic is truly mind-blowing. How can a two-dimensional image encode three-dimensional information in such a precise way?
Well, this variation in image density, directly related to the distance from the source body, has been meticulously analyzed by both analog devices, like the VP8 image analyzer back in the 70s, and later, digital computers.
And what do they find?
They could render incredible three-dimensional maps of the shroud image, especially the frontal one. You can see a famous example in Figure 81. In the source, it's a VP8 three-dimensional rendering of the facial area. The computer, fed only the density data from a 2D photo, literally constructs a topographical map of the face with peaks and valleys corresponding to the darkest and lightest parts of the image. It reveals this inherent three-dimensionality.
So the computer sees the 3D shape hidden in the shading. Did STERP confirm this experimentally?
They did. The STERP team specifically worked to characterize this spatial distribution with scientific rigor. They demonstrated this relationship quite elegantly, actually. They carefully enfolded volunteer subjects in a full-scale shroud model, meticulously measuring the distances from various points in the body to the cloth.
Yeah.
They confirmed that the closer the enfolding cloth was to the body, the denser the resulting body image appeared on the cloth in their models. For example, one of the densest body image areas on the actual shroud corresponds to the tip of the nose.
Which would be pressed right against the cloth.
Exactly. A point where an enveloping cloth would inevitably be in direct, tight contact with the body. Conversely, areas where the cloth would have been slightly raised, like perhaps over the eye sockets or parts of the cheeks, show lighter image densities.
Okay, that makes sense. The source also points out two further observations related to this.
Yes, they're often listed as separate evidence points, but can really be seen as logical extensions of this incredible 3D encoding. First, body image fibers are visible even in apparent non-contact zones between the body and the shroud. Think about the sides of the nose or cheek areas where the cloth might not have been directly touching, yet there's still image there.
So it's not purely a contact image.
Doesn't seem to be, no. This suggests the image formation isn't solely a contact process. Second, the image density is noticeably less dense in these non-contact areas than in the direct contact zones. So the convex hills of the face, like the eyeballs under closed lids and the very tip of the nose, are more clearly represented and denser than the concave hollows, where the cloth would naturally lift slightly off the body. The tip of the nose, as we said, being one of the most evident areas of direct contact, is also one of the densest image areas.
This characteristic is just profoundly unique. It defies any simple contact-only or flat projection formation hypothesis. How could a 2D image encode such precise 3D information from a wrapped object?
It points to a process involving some form of energy or interaction that perhaps emanated from the body, with its intensity inversely correlated to distance, imprinting itself onto the cloth.
But what kind of energy or process could possibly transfer this distance-encoded information from a 3D object onto a 2D surface in such a precise inverse relationship?
That is one of the core questions. It takes us far beyond our conventional understanding of how images are formed.
Okay. Building on that concept of a wrapped body, we have B4, geometrical distortions consistent with a wrapped body.
That's right. The distortions you actually see in anatomical features like the hands, the calves, the torso, they're exactly what you'd expect if a three-dimensional human body lying on its back were wrapped in a flexible linen cloth like the shroud.
And there's something about the direction of mapping.
Yes. Furthermore, the mapping of image features from the body to the cloth for the frontal image is described as being more or less vertical. This corresponds directly to the direction of gravity if the body were lying horizontally.
How do scientists analyze that?
Well, to understand this, you can consider Figure 82 in the source material. It illustrates three possible primary information transfer paths from a point on the body to a corresponding point on the cloth. There's path E, which represents transfer perpendicular to the body surface, so straight out from the skin. Then path A, which is perpendicular to the cloth surface, straight through the linen wherever it happens to be draped.
Right.
And finally, path P, which is vertical or parallel to the axis of body cloth symmetry. This aligns with gravity if the body is horizontal.
And which path fits the shroud image?
What's absolutely critical here is that scientific analysis, particularly computer modeling, has shown that only path P, that vertical projection, yields the relatively undistorted representation of a human body as seen on the shroud.
What would the other paths produce?
If the image formed via path E or path A, if the information simply radiated perpendicularly from the body's surface or directly through the cloth, you would get severe, anatomically nonsensical distortions, especially in areas like the face. The source explains that images formed by multiple undirected vectors, like simple diffusion, convection, or surface radiation, would typically result in low-resolution, blurry images anyway.
But the shroud image is spatially resolved with high resolution, particularly the face.
Exactly, which makes this specific apparent vertical projection mechanism incredibly significant and, frankly, puzzling.
Is there other evidence for this wrapping distortion?
Yes. Furthermore, the shroud image exhibits a noticeable lengthwise distortion that is also consistent with a wrapped body. The flat frontal image, laid out, measures about 6 feet 4 inches or 1.93 meters from the crown of the head to the tips of the toes.
Okay.
Whereas the flat dorsal image, the back image, measures about 5 feet 10 inches or 1.78 meters from the top of the head to the top of the heel.
That's quite a different 6 inches. Why?
This distinct difference in measurements, along with the observed distortions of the limbs, is entirely consistent with the geometrical layout of the cloth, draping a three-dimensional body lying horizontally on its back. Perhaps the model suggests with slightly raised knees and head, just as a body might be prepared for burial. The cloth has further to travel over the front contours than the back.
So this characteristic heavily reinforces the idea that the image was formed on a flexible cloth draped over a real, anatomically specific human body.
It does. It's a powerful argument against any hypotheses involving images derived from flat objects like paintings or even bas-reliefs, which wouldn't produce these specific and consistent three-dimensional draping distortions.
It's another piece of evidence pointing to a dynamic interaction with a real draped form.
Which logically leads us straight to B5, the absence of side images. Meaning, a key observation is that the shroud displays absolutely no discernible side images of the body, nor the top of the head, in the area between the frontal and dorsal images.
So where the cloth would have folded over the sides?
Exactly. Where the cloth would have draped over the sides of the body and head, there's no body image. The only major discoloration in that specific area is an ancient water stain, which is clearly identifiable as separate from the body image itself.
And this absence is significant.
It's as telling as the presence of other features. As we just discussed with B4 and the projection paths, this absence strongly suggests that the image formation involved a primarily vertical mapping that specific path P. Because if the image formation had followed path E or path A, radiating perpendicularly from the body or cloth surface, you would undeniably expect to see highly distorted side images, particularly in curved areas like the face and shoulders. Figure 83 in the source provides a striking visual example of the kind of severe image distortion you would see with those other projection paths.
A distortion that is conspicuously absent on the shroud.
Conspicuously absent. So what kind of image formation mechanism would only produce these vertical projections, avoiding lateral or side images entirely?
It puts more very specific constraints on hypotheses.
It does. It constrains hypotheses involving any form of diffuse radiation, direct physical contact from all angles, or even simple painting. It strongly supports a highly directional, perhaps even collimated formation process that specifically projected information vertically onto the draped cloth, somehow bypassing the sides. This is another scientific puzzle piece that significantly narrows the field of plausible explanations.
Okay, so we have these geometric and projection characteristics. Now we arrive at a truly fascinating and incredibly important characteristic. B6, the nature of the red stains.
Yes, the red stains are confirmed to be human blood. And, perhaps even more intriguingly, they're generally surrounded by serum retraction rings that are completely invisible to the naked eye, but fluoresce brightly under ultraviolet light.
And it's worth noting that specific phenomenon of UV fluorescence was entirely unknown to science until the 19th century.
That's a crucial point. The scientific regression behind this confirmation is really important to appreciate.
Yeah.
In 1978, during their testing in Turin, the STIRP team meticulously collected sticky tape samples from various areas, including from these alleged blood areas.
Right.
Then, in 1980, two key STIRP team members, biophysicist John Heller and chemist Alan Adler, published their findings. Using advanced chemical tests for the time, they confirmed that the alleged blood on the shroud was indeed actual blood, though their initial chemical tests couldn't definitively classify it as human versus animal blood.
But their research didn't stop there, did it?
No. In 1981, Heller and Adler extended their research using more sophisticated serological techniques, methods used to study blood serum. They successfully identified two major blood serum proteins, albumin and immunoglobulin, which is also known as an antibody.
And that narrowed it down.
Yes, that breakthrough research allowed them to classify the blood as private blood. Then, a few years later, in 1985, an Italian professor, Bema Bologna, a respected pathologist, used even more refined serological techniques. He confirmed Heller and Adler's findings on immunoglobulin and, crucially, identified the presence of M, N, and S antigens.
Antigens being markers on blood cells.
Essentially, yes.
Yeah.
His research showed the blood on the shroud is M positive, N positive, and S positive. Now, here's the key. While M and N antigens are shared between certain primates and humans, the S antigen is exclusive to humans.
So the S positive result
Conclusively indicated human blood on the shroud. That was a truly definitive finding based on the science of the time.
Has this been revisited since?
Well, in 2013, K.P. Kearse, a respected shroud researcher with a strong background in immunology and glycobiology, published a paper that specifically emphasized Bologna's study as the direct and most robust confirmation of human blood based on the available data. Kearse also highlighted the major advances in serology since the mid-1980s.
Things have improved since then.
Dramatically. He noted that a simple, rapid, and highly accurate confirmatory test for distinguishing human versus animal blood, requiring only a few microliters of sample, has been available since 2010. So he advocates for new confirmatory testing, if and when samples become available again, stressing, rightly, the paramount need for peer review in such a significant area of study.
Beyond the serological tests, are there other reasons to think it's real blood from wounds?
Yes, there are compelling forensic reasons. Medical forensic scientists examining the shroud agree that many of the blood stains aren't just simple flows of whole blood. They often appear to be exudates from clotted wounds transferred by direct contact.
Exudates, what are those?
Exudates are complex materials composed of serum, fibrin, white blood cells, stuff that leaks from blood vessels during inflammation or injury. It indicates a more profound wound response than simple bleeding. These exudates seem primarily associated with the numerous scourge wounds visible on the body image.
And those serum halos.
Ah, yes, those elusive serum halos surrounding many of the blood stains. Invisible to the naked eye, but dramatically fluorescing under UV light, they're highly significant. That specific technology for detection, UV fluorescence, simply didn't exist until the 19th century.
Making them impossible for a medieval forger to anticipate or replicate.
Exactly. The presence of human blood with such complex characteristics, the distinct serum rings, the presence of exudates, the specific antigen profile is profoundly significant. The fact that the serum rings were only discoverable using 19th century technology speaks volumes, potentially, about the integrity of the evidence and the shroud's age.
And the detailed forensic analysis points strongly to a real wounded body that suffered traumatic injuries, not just an artistic creation.
That's certainly what the forensic interpretation suggests.
This deep analysis of the blood leads us then to B7. Blood stains appear both on and outside the body image.
Yes. While the majority of the blood stains align perfectly with areas of direct body contact, consistent with how blood would transfer from a wrapped body, other blood stains are noticeable. Notably, there are stains off the left foot, stains below the small of the back, and stains off the right elbow. These are consistent with flow patterns away from a body that was specifically wrapped in the shroud cloth.
You can see examples of this in Figure 84 and Figure 85 in the source material.
Correct. And crucially, scientific studies indicate something about the timing. The blood in the hair, particularly on the back of the head, seems to register with blood that would have transferred from the sides of the face while the shroud was wrapped around the body, but before the occurrence of the imaging phenomenon itself.
So blood first, then image.
This chronological detail about the blood being present before the image formed is incredibly important, and is further supported by our next characteristic, offering a clear sequence of events.
And that's B8. No image can be found under the bloodstains. This sounds foundational.
It is a foundational discovery. Careful study by Stirp, looking right at the boundary where the colored image fibers meet the bloodstains and serum rings, unequivocally revealed no image underneath the blood or the blood serum. The image color consistently and precisely terminates right at the boundary of these bloodstains and/or their associated serum retraction rings.
It stops right at the edge of the blood.
Exactly, it doesn't go underneath. This critical finding was also experimentally confirmed. Tests involving the enzymatic removal of blood from blood-coated fiber samples taken from elsewhere confirmed the complete absence of image underneath where the original bloodstain had been.
And what are the big conclusions from this?
This finding supports three very significant conclusions, which fundamentally constrained any hypothesis about the Shroud's creation. First, the bloodstains, the wounds themselves, and their associated serum retraction rings must have been on the cloth before the imaging phenomena occurred. This establishes that clear chronological sequence: blood first, image second. Second, there is no evidence on top of the bloodstains or serum retraction rings of any materials artistically applied to create the image. This again rules out painting or artificial enhancement over the blood.
Right.
And third, there is no evidence of any major damage to the bloodstains or serum rings from an artistic effort to create the image, for instance, from using a hot bas-relief statue, which would likely scorch or alter existing dried blood.
Wow. So this characteristic is absolutely foundational to understanding the Shroud. The image respects the existing blood.
Precisely. Whatever caused the image happened after the blood was already present on the cloth. This definitively rules out any artistic method that would have painted over or somehow altered the bloodstains during the image creation process,
Providing a clear and undeniable sequence of events. The body was wounded, it bled, blood transferred to the cloth, and then the image formed around that pre-existing blood.
That's the sequence the evidence points to. It adds another layer of profound, well, authenticity seems the wrong word, but physical consistency to the evidence.
Okay. Let's move to B9. The Shroud enveloped a dead human body. This sounds like a summary point.
It is. This characteristic synthesizes compelling evidence from various points we've already discussed, broken down into three key premises: the clear presence of a body shape, that it was an actual human, and that the human body was indeed dead at the time of enshroudment.
Okay, let's recap the evidence for body shape.
For the body shape, we can reinforce that remarkable three-dimensional correlation we discussed in B3, where image density directly relates to body cloth distance, showing a clear topographical map. We also have the interpretation of those lateral two-dimensional distortions from B4, which are perfectly consistent with a flexible cloth draping over an actual three-dimensional body shape.
And those off-body bloodstains.
Exactly, from B7, like the one off the right elbow. Those are consistent with direct contacts from a wrapped, contoured body, not a flat object or a two-dimensional rendering.
Okay, that covers the shape. What about the evidence for an actual human body?
Here we recap the definitive confirmation of human blood from B6, based on those sophisticated serological tests identifying human-specific antigens. Furthermore, the medical forensic research on the wounds is highly compelling.
Like the scourge marks.
Yes. Stirp researchers V. Miller and S. Pellicore meticulously documented that many of the numerous scourge marks, when illuminated by ultraviolet light, remember, a 19th century technique, show not just generalized bruising, but minute specific scratches, often appearing as 3 or 4 parallel lines.
Tiny detail.
Incredibly fine detail. This is precisely what would be expected from the impact of a Roman flagellum, suggesting a direct impact on real human flesh, not just an artist's impression. Additionally, remember the numerous bloodstains with different flow directions, some consistent with a vertical crucifixion position, while others clearly indicate post-mortem horizontal burial. This confirms a multi-stage traumatic event involving a human body.
And finally, the evidence for a dead human body.
Here, the most striking detail is that significant wound to the right side of the chest. This wound is associated with blood and also what appears to be pericardial fluid that seems to have pooled into the body after death. And crucially, it exhibits all the classic characteristics of a post-mortem wound.
How can they tell it's post-mortem?
Forensic analysis shows a distinct separation of blood clots and clear serum in the flow from that wound. This is consistent with fluids emanating from a body after death when circulation has ceased and blood components begin to separate differently than in a living person. This particular detail is extremely difficult to fake or create artificially.
So it adds powerful weight to the conclusion that a deceased human body was enveloped by the Shroud.
It does. This point truly synthesizes much of the prior evidence to present a unified and scientifically robust conclusion about the nature of the body that appears to have generated the image. The specific, medically consistent details, like the UV-revealed scourge marks and the post-mortem chest wound, are particularly compelling for a scientific assessment. They far exceed what would typically be expected from medieval artistry.
But here's another incredibly intriguing and crucial point that seems almost contradictory. B10. The shroud shows no signs of putrefaction.
Yes. Despite all the compelling evidence that a dead human body was indeed wrapped in the shroud, there are no evident signs of decomposition or putrefaction on the linen, which would typically start to occur relatively quickly after death.
Where would you expect to see those signs first?
Scientifically, signs of decomposition would usually first be noticed around body orifices, the nose, the mouth, as these are the initial points of bacterial activity. However, no such signs, no darkening, no blurring of the image, no gas-induced distortions are associated with the shroud images of these sensitive areas.
And no fluids.
Significantly, there are also no fluid stains on the cloth that might be associated with the decomposition or liquefaction of a human body, which would inevitably leak from a decaying corpse over time.
So what does this characteristic suggest?
It strongly suggests a very limited duration that the body was enveloped by the cloth. What are the scientific implications for the duration of contact and, perhaps even more profoundly, the speed of image formation? It significantly constrains any natural decomposition hypotheses that would involve a body remaining in the shroud for an extended period, say, several days.
Because if the body had remained for even, say, 36 to 48 hours?
Some level of decomposition fluids and noticeable changes to the image around the orifices would almost certainly be expected. The absence of these features implies either a rapid departure of the body from the cloth or a very rapid image formation event, or perhaps both.
Another layer of mystery. Okay, finally, we arrive at B11. There are images of finger bones.
Yes, images of finger bones extending all the way to the wrist on the left hand of the shroud body image. Forensic studies of the shroud's hand area reveal these subtle but discernible images of metacarpal bones, the bones that connect your fingers to your wrist.
Are these easy to see?
Not at all.
No.
These internal structures are incredibly difficult to observe, if not impossible, in standard front-lit positive and negative photographs. But they become somewhat easier to detect through more advanced imaging techniques, particularly using ultraviolet light, backlighting the cloth, and applying digital contrast enhancement. Figure 86 gives some idea.
And specific researchers highlighted this.
A truly significant contribution in this specific area came from Dr. Alan Wenger, who had a background in medicine, and his wife, Mary Wenger. Their meticulous work using overlay techniques and special edge-enhanced photographs, like the one shown in Figure 87, quite clearly show these metacarpal bones. It suggests an almost X-ray-like quality to the image in that area.
X-ray-like. Are there other examples?
What's even more intriguing and really stretches the boundaries of our understanding is that similar techniques employed by the Wangers have suggested the identification of not just finger bones, but also potential facial bones and even images suggestive of teeth within the shroud's facial image.
Bones and teeth.
It's controversial, but that's what their analysis suggested. You can compare the subtle density of colored fibers in the eye area, shown in Figure 88, with the density in the nose area, which we discussed under C2 and B3 regarding superficiality and 3D encoding. These subtle variations in image density might, some argue, hint at underlying internal skeletal structures.
This is truly unprecedented in any known image formation process. How can an image primarily of a surface, the body's exterior, also contain details of internal skeletal structures?
It pushes the boundaries of known physics and chemistry, doesn't it? It adds yet another profound layer of scientific intrigue. It implies an interaction at a molecular level that somehow reads not just the surface topography, but perhaps the underlying density or mass distribution, and then translates that information into a superficial chemical alteration of linen fibers.
It suggests a process that fundamentally defies our current understanding of how light or chemical interactions typically work on surfaces. It challenges our assumptions about the very nature of energy transfer and image creation.
That complexity, that defiance of simple explanation, is precisely what makes the Shroud such an exceptional scientific anomaly.
Well, we've certainly taken a profound deep dive today, haven't we? We've meticulously explored these 17 crucial Class 1 evidence characteristics of the Shroud of Turin, really dissecting them with an academic lens.
We have. We observed properties related to the cloth itself. Its near identical optical densities front and back. Its astonishing extreme superficiality. That fascinating double superficiality only on the frontal image, not the dorsal. and the definitive absence of any extraneous material like paint or evidence of capillary flow in the image areas.
And then we delved into those powerful characteristics related to the body image itself. Its perplexing negativity effect, acting like a photonegative. Its high resolution combined with that strange vanishing effect up close. The incredible 3D encoding that directly correlates image density with distance from the source body.
Right. And the geometric distortions entirely consistent with a rock body, coupled with the significant absence of any side images, that supports a very specific kind of projection.
We also uncovered the undeniable presence of human blood confirmed serologically with those unique, historically undiscoverable serum retraction rings. We saw how bloodstains appear both on and outside the body image, consistent with wrapping. And perhaps most crucially, the fact that no image can be found underneath the bloodstains, firmly establishing that the blood was there before the image formed.
Absolutely. Then we covered the compelling forensic evidence indicating the shroud enveloped a dead human body based on wound analysis, blood flows, and that specific post-mortem chest wound. And importantly, alongside that, the complete lack of any signs of putrefaction, suggesting a short time frame.
And finally, the truly astounding, almost unbelievable presence of images apparently showing finger bones, hinting at an imprint of internal skeletal structures.
Our mission today was really to unpack these 17 characteristics in detail. And collectively, as we said at the start, these are precisely what scientists and researchers use to critically evaluate all the proposed image formation hypotheses. So hopefully you now have a powerful, scientifically grounded understanding of the shroud's physical evidence.
It allows you to engage with the topic on a much deeper, more informed level.
Exactly.
So you're now equipped with a detailed academic understanding of the shroud's unique characteristics, moving far beyond simple anecdote to a precise scientific appreciation of this remarkable artifact. This isn't just a historical curiosity. It's clearly a profound scientific puzzle that continues to challenge our comprehension of the natural world.
Indeed. And it leaves us with that ultimate question. Given this truly remarkable, even unique combination of scientifically observed characteristics, a superficial image that is also a photographic negative,
Right.
that encodes 3D information, shows no paint or capillary flow, appears after bloodstains were deposited, and seems to reveal even internal bones, all while being on a cloth that apparently covered a dead human body, showing no signs of putrefaction. What kind of phenomenon could possibly account for all of these features simultaneously?
What are the limits of our current scientific understanding when faced with such an object? What questions does this leave you, the listener, pondering?